Start sending us your video from streaming software. Yeah, there we go. Okay, give me a second. Seems I am streaming there now. Yeah. Yeah, definitely. Yeah. I mean, you're talking about Shivapi so much, man, that it was just a matter of time before you had something like that. Give me 2 seconds. Never quite as it seems. All right, great. Super, fellas, super. All right, what do we wanna? Where are we? Where are we? So yeah, as you saw, right? The hard drives have arrived. Actually, I just plugged them in maybe 20 minutes ago. So basically, here they are. So we got 2 of those. I've never heard of this brand before, but if you remember, we ordered them maybe last stream, right? Let's take a look at that. So, and we now got them. So, yes, as you can see, they just arrived literally like an hour ago. So yeah, I've never heard of this brand in my life, but we ordered them because they're like almost free, and for what we want to try to learn and attempt, it's great. And then if you remember, during one of the streams, I use it for Raspberry Pi 4, works great, blah blah blah. So great, okay, so that's awesome, right? So if we go to our repo over here, so if we take a look at this thing over here, so let's take a look. So I think I plugged it. Where did I plug it? I plugged it into, as you can see, a Raspberry Pi 2 and Raspberry Pi 3. So basically we should see them there, right? Let's take a look at that. So SSH RP3 and what was it? LF? No, what was it? Okay, let's take a look at this. So what was it? The LSBLK. Okay. So yeah, here it is. So it's reading the drive now. So let's just format that thing, right? So it's not mounted anyway, so we're just gonna fdisk it, right? So we're gonna sudo fdisk dev sda. So we're gonna do the what was it? D, right? Nah. What was it? M for help. Quit, create, empty. Oh, fucking bots, man. What is this crap? Shit. Yeah, that sucks, man. Fucking Twitch, dude. How can I, like, can I remove them or what? Can I ban them? What can I do? Shit, man. Oh, fucking no-lifers, man. So terrible. Doesn't my neck hurt? No, my neck does not hurt. Don't worry. Don't worry. All right, let's format that. Wow, that's actually fast. Okay, cool. That's great. So we have a story for this anyway, right? So we could, in theory, just run our playbook, right? We have partition and format, right? So we could, in theory, just do that. But it's okay. Let's just do it disk by disk again. It's fine. And then we said, Yeah, and then we do the same here, right? Yeah, fuck them. I don't actually see the... I genuinely, if you're saying that people are paying for this, that crap, spammy crap, that is very sad. That is very sad, yeah. Because there's literally no point. Okay, no partition yet, so we're gonna create a new one. We'll just pick the defaults. We're gonna save that, right? And then we'll do pretty much the same. We'll just format that crap, right? So we'll just do, is it... Yeah, so we'll do... Yeah, but what is the purpose? Does anyone know? I don't understand. Like, why would that somebody do that here? Like, what do they gain? It just makes absolutely no sense. Why would you spam someone else's stream? That's totally like unnecessary. Like. Revez, my friend. Good evening. No, I have not. I have not worked on that. I kind of gave up on that because yeah, it's just 2 pins right there. So yeah, so we moved to something else. These hard drives, new hard drives have arrived, 2 of them. So I just plugged them in. And yeah, fuck, we forgot to, actually, let me just update this as well in the docs. We forgot to create a mount point, so we need to do this on both disks. We should have just run but it's okay, the Ansible thing, but it's okay. Let's just clean that up anyway. I'll actually clean this up off stream, it's fine. No, it's okay. I mean, it's just very childish. I don't get it. It's like, okay, well, this is a very childish platform after all, right? So maybe I should lower my expectations. But yeah, it's just a waste of time. I don't get it. Right? Just very dumb to do that type of stuff, right? But that's what it is. Internet is a jungle, right? So what can we do? Not much we can do about that, right? Give me 2 seconds just to this. I'm gonna get an OCD from this. So, oops. I'll just I just need to format it. Okay. Create a new. Okay, and let me maybe read it like this. Mount a new partition. So let's create a mount point, right? So we're gonna say how should we call it? Just call it storage. So let's say. And where we want to do it the MIT, right? Actually, maybe we already have. Yeah. All right, so we kind of already have that, right? So we just really need to do as the B1, and then we're gonna do storage, right? And then let's reload. Yeah. Indication complete. Cool. So that's great, right? So now technically this should be mounted, right? Storage should appear somewhere. Here it is. Beautiful. Great. And of course we want to update the FS tab, right? Because we need this. So let's do that. So we'll get the UID, right? Oops. So we'll get the UID, SSDB1, right? So here's the UID. So we'll grab that bad boy and we'll smack it somewhere over here. Not the NAS, Raviz, we're gonna do Longhorn. We're gonna learn about Longhorn today, right? So I've never used Longhorn. I've recently found about it from some of you guys. So yeah, so we're gonna do I think it is. I think it is. Yeah. Yeah, so you can see this is actually wrong here. So we need, and this is when we were kind of testing the, no, fuck. Wait, so what was it? So we need to nuke all of these guys, right? And then we need to do things like this. Where's our UID? Over here, right? So we'll grab that fella. We'll say storage. And then we'll paste in the UID, right? Yeah, that should kind of in theory be correct, right? So let's save that. Yes, okay. That's super nice, okay. And let's reboot this device. And then let's go to SSH RP3. So we have it there, right, as the A. So we're going to do the same thing here. We're going to get the UID from this fella, and then we should be done. We just want to make sure that it does it on boot, right? MAGA, yeah. Good evening. United States of America. Firmware, ah shit, okay. Give me 2 seconds, okay. And we're gonna pretty much do the same here, right? I guess we can do it because they're using partial IDs here, right? I don't think it matters logically, right? So we probably, ooh, okay. Yeah, we haven't done the previous part here, so we need to be careful about this because we would try probably to mount something that doesn't exist, right? Yeah, exactly. So we need to do this. We need to do that, and then yeah, we forgot really to mount, right? So we'll do this, and then storage, right? Yes. We want to reload this bad boy. We want to enter. Why did you switch from RAID to Longhorn? I'll show you, because I researched a bit, and apparently for the Kubernetes in general, Longhorn is simply a better solution. And we're gonna read why. But fundamentally, like, RAID is essentially RAID 1 would be a single point of failure in our cluster. Because let's say that Raspberry Pi dies, we're fucked, right? Whereas with Longhorn replicates the data on n number of nodes, either all of them or the number that you provide. So essentially now we can plug 4 hard drives, so 1 drive in each Raspberry Pi, and then Longhorn is going to replicate the data across them and over network, right? So you still get kind of the RAID 1 like solution to such a problem, right? But you don't introduce a potential single point of failure, which would be like if something happens to that node in which hard drives are connected and where RAID 1 is set up, then it doesn't matter if everything else is HI, right? Like high availability, because my database would be dead, right? If you're referring to Longhorn, I don't know. I've never used Longhorn, so we're gonna learn that together now, right? I have no idea how to do that. That's what we're gonna learn now. I absolutely have no idea how Longhorn works, and I just had a little chat with ChatGPT, and I asked it the right questions, such as, okay, let's talk a little bit about let's talk a little bit about it, and you tell me what it means. Okay, so we can see that it's fine here. Let's reboot this guy. And I have 2 other old disks, so we could in theory plug these other 2 disks. Essentially, we could plug, we have now a drive for every Raspberry Pi. We have brand new ones, which I'm gonna order 2 more if this ends up working. So let's take a look, right? Let's take a look. Cool, okay. So let's SSH into this fella here. Okay, cool. And let's do the DF. What does the DF stands for? Give me 2 seconds. Disk free. What the fuck is that name? Disk free, also known as DF, which is powerful utility that provides valuable information on disk space utilization. Disk free. Oh, okay, makes sense. The DF command displays information about file system. Cool. Okay, I'm gonna actually, because I'm not a Linux expert, I'll just DF. What does it do? Actually, let's take a look. Unix args explained. There was that website I used. Yeah, explain shell. So let's see what it means. Explain shell. H, human readable, print file system type. Nice, okay. Thank you. Nice. Cool. Super. So is this mounted? Did we actually set it to mount and boot? We had. Okay. So let's write as we learn together. Some of you might say, "Oh, I know this for my whole life." That's great. I'm happy for you, but I do not know all of these. So we're gonna just just gonna do this, right? Is there a way? Let me just take a look at one. Is there a way to somehow like? Ah, nice. Okay. So I'm just going to do it like this, right? Because here for the explainshell.com, we can kind of see what each one of these things do. So I'm going to do with we're going to use btop, right? And utop. Btop. No, what was it? Wasn't it btop? I think it was btop, right? Yeah, it's btop. Yeah, nice. So we're going to do btop here and htop. Yeah, there's utop and there's btop and yeah, but isn't there a... Yeah, okay, but okay, sure. H-top, right? Yeah, that's the kind of less sure. Got it. Sure. Let me just for the sake of this guide that we're gonna eventually share with the world. Well, hopefully we're gonna write something that's super cool and useful for others. So let's just put these things here as a point of reference, and then whenever we need them, we can just click and see what arguments. It's just easier for me to kind of have them explained here, right? Because it's more readable for me. Oh, Folks is here. I love you, dude. Folks is my teammate and my friend. He's a designer in my team. I love you, Habibi. My dear Habibi. Oh, dude. Maga. Oh, it was you. Good. I instantly knew now. I'm tired, man. And I'm gonna stream. Oh, actually, countdown. Because I'm planning to stream only for 2 hours. I need to go to the gym. So let me just... Is there like a way to show a countdown of some sort, like... Ah, fuck you, man. Like, I want to do 120 minutes. Window clock. What the fuck is window clock, man? Just show countdown Twitch stream. I don't actually care about you guys. I just need this for myself to... The fuck, man? Ah, okay. 2 hours. Cool. All right, cool. And how do I use this crap? Oh, I see. Okay. Give me 2 seconds. Oh, I see. All right, well, whatever, man. Come on. How do I add that? So I go here, browser, countdown. Cool. All right, great, beautiful. All right, I need that for myself, not for you guys, like I said. Okay, great, 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 cool. I need to go to gym later, and it's already super late, but I promised I'm gonna stream, so I just wanted to keep to that promise. Okay, cool, guys, great, great, great. Okay, so Longhorn, right? So let's just learn together about Longhorn, right? So let's go to this thing, and so like I said, I didn't do anything ever with Longhorn, ever. I have no idea how it works. I just, so I'll just find the discussion I had so we can learn it together. Because somewhere here I discussed with this guy, hey, I hope that it was here. Huh, where is this crap, man? Ah, okay, so it's here, right? I think it's somewhere here. Yes, 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 yes. Okay, let me just give you the context, okay? Cool, cool, cool. Here it is, here it is. All right, so this is what I asked this guy. What can Longhorn solve for my K3S Raspberry Pi cluster? Does it, for example, replace 2 hard drives in RAID 1? That's what I asked, right? I want to host Postgres and Redis myself on one of the Raspberry Pis, and my idea is to do it outside of K3S because I've heard one of them shouldn't feel stateful. Okay, summary of your setup, blah, blah, blah. What is Longhorn? Longhorn is an open source cloud-native distributed block storage solution. And now we need to break this down because let's make sure we actually understand what the hell does this even mean. So let's ask right questions, right? So what is what do you want to ask here? Well, what is a block storage, right? That's probably the first question you want to ask. You cannot just read this and skim through. Specifically designed for Kubernetes, right? It's designed to create highly available, replicated. Actually, we're not going to use Helm until we learn Kubernetes good enough, right? So yes, I know that Helm would solve it, but that would take away we would lose on the knowledge, right? So we're going to use kubectl manually for some time until we feel confident that, hey, I can actually do this, right? And then once we can do it, we're going to add that abstraction, right? Because I don't want to pretend that I understand something that I actually have absolutely no clue about, right? So I want to be careful and, you know, I don't want to, yeah. Actually, basically, so let me just show you. So essentially, yes, I'm a full stack engineer. I work as a tech lead, so I'm not a per se DevOps engineer, right? So I have started this idea of this project to set up, basically we're setting up this cluster here. This is the Raspberry Pi cluster, right? And this is the repository that I'm writing. So essentially by the time we finish, it's a huge project where we basically want to host our programmer network platform there. And by the way, give it a star to this repo if you care about the progress. But fundamentally, yeah. But am I a beginner in Kubernetes? Absolutely, absolutely. I've been programming for 20 years, but when it comes to Kubernetes, yes, I'm definitely a beginner, no question about that. But we are learning fast. But yeah, Helm, I understand that Helm would solve and speed things up. But again, I genuinely want to understand Kubernetes is hard, especially when it comes to more complicated setups with multiple servers at different locations and ingress. And how do I know? Because we are GCP partner at where I work, so we use Kubernetes real one, like K3S. Is just as part of GCP. So a lot of these things that we're doing here are very fundamentally different because we are doing bare metal here versus, yeah. Okay, but this is just for the context. So if you expect a Kubernetes expert this couple of streams, I'm sorry, that's not who I am. we might become very good at it together, but right now we are, at least on behalf of myself, I'm not. Longhorn is an open source cloud native distributed cloud storage, blah, blah, blah. Data replication replicates across multiple nodes, automatic recovery, recovers from node failure, this failure, right? So already when you read this, you're like, shit, man, this sounds great. This is like a RAID 1 on steroids, right? It's like, okay, like sounds like RAID 1, check. Automatic recovery, check. Beautiful, right? Snapshots and backup, check. Wow, right? And you're like, all right, so you got me already here. And then let's read further. Longhorn versus RAID 1, that was my question. You know, RAID 1 mirroring and Longhorn achieve similar goals, but they solve problem of data redundancy very differently, right? Let's compare them. Redundancy type RAID 1 mirrors data across 2 drives on the same node, works at disk level, right? So yeah, you have hard drives, and that's how it works. Replicates data across several nodes in Kubernetes cluster, works at more abstract block level across multiple nodes. Huge difference, right? Because you can see that if my Raspberry Pi in which these disks are plugged, it's true what Revez is saying, we could have created a NAS of some sort as well. So NAS is another solution. I don't think it's one, or it would be a third solution to this. I could have created a NAS here, exposed it to my network, so that could have also worked. But the question, why this? I just feel that if we're going to learn this together, it's better to learn something native to the Kubernetes itself, right? And this seems more native to Kubernetes, and it seems fairly, I cannot say popular. Please take my advice with a grain of salt, because again, but I would imagine that because it's a cloud native solution for Kubernetes, that you would rather do this than a NAS or a RAID 1 or something like that. So this is my impression so far. Am I right? Yeah, a lot of home projects, but just because we're gonna host this at home, keep in mind we will not treat it as a home lab or something like that. We will actually host Programmer Network, which is production project, which is live. We will attempt to store it here indefinitely, right? So it's not just a pet thing. We will try to do it properly. So we want to do it properly, right? Scope generally limited to a single node. So as I said, RAID 1, if my node, one of the nodes fail, well, my database is gone, right? So, ouch. Replicates across multiple nodes in Kubernetes, right? Failure handling, if node goes down, RAID is useless. You'll only tolerate disk failure per node. Can withstand cluster node failure. If node goes down, your data is still accessible on another replica. Super awesome, right? Requires disk level management, MDA, DM, software RAID. Managed directly to Kubernetes, making it more cloud native, blah, blah, blah. Scaling. RAID scales with disk size, more drives, more capacity, can dynamically scale across nodes, offering blah, blah, blah. Snapshots, limited functionality, usually requires external tools. Snapshots, backups, and restores are natively supported. Type of workloads, best suited for traditional non-Kubernetes systems, specifically designed for Kubernetes environments and can be used with stateful sets, persistent volumes, and stuff. We haven't yet together touched persistent volumes nor stateful sets. So as part of this thing, we will hopefully learn what that is. I think so far in this repository we created, we have practically only touched like very basic stuff. Namespaces, deployments, services. We took a look at the, we exposed basically a cluster, like I believe here in service exposure, we have used the cluster IP initially, but then we have also used node. So we exposed this, and if you remember, I then created a NAT, network address translation on my router, and then we exposed that to the world, right? But there's, So basically, anyway, going back to this, so this is fundamentally why. So the question is why RAID, why this over RAID 1, right? That's why. Now, when I asked the question about Redis, right, it gave me a little bit different answer. It said, hey, well, Redis is a little bit different, Alex, it said, right? It said because Redis has its own Redis Sentinel or Redis cluster, you wouldn't typically use RAID 1. So basically it's saying, hey, you can just as well host, I guess, Redis outside of the cluster because it has its own replica sets, let's just call them like that. So we don't know. We're gonna start with because Redis is an in-memory database, so I'm sure that we can't. It needs to be lifted up. So all the nodes we had this issue at work a couple of months ago, especially because we're also using nodejs for some APIs where we actually had to lift the Redis up, especially because of all of the pods would then recache. They would have their own cache. So, but anyway. So that's kind of it. That's it. That's what we're gonna do. And I guess, yeah, we can start with the robot, as I call it, OpenAI, or we can start with the documentation, right? I always like to read the official documentation, right? Okay, so let's. I actually already know that because we're using. I've used S3 before, and I've used. Cloud storage we use now, but let's just, for the sake of this stream, let's say, what is a block storage? Right. So as I said, we need to ask questions as we read. Things are okay. Block storage is a type of data commonly used in cloud computing and enterprise environments where data is stored in fixed size blocks, typically a sequence of bytes on a physical disk. Each block is treated as an individual unit of storage and given a unique identifier, allowing it to be retrieved, written, blah, blah. Fundamentally, block storage operates by dividing the raw storage into blocks and organizing it in a way that allows for low-level, fine-grained read and write operations. This makes block storage particularly well-suited for scenarios that require fast database-level access and transactional, blah, blah. Okay, I'm not going to read this. Too much crap written here. That's what it is. We just bought 2 hard drives for this example. These are 128 gigs. These are the fastest I could find, and if I could have found the smaller ones, I would, but this is the smallest. We have 4 disks, but we just bought, for this project, today these 2 guys arrived. So if they turn out to be working, this super cheap, it's like 20 euros. This was it's highly rated, I don't know why. So if this turns out to be good, we're gonna get 2 more. I'm gonna order 2 more. I basically ordered 2 of these and 2 adapters, right? 2 of these guys. And it seems to be working really well so far. Let's see. Yeah, let's try with this. Let's try to learn this because this seems almost too good to be true. They also have NFS or S3 compatible block storage. So I mean, technically, we could also like back this up to S3 or whatever in theory. I don't want to do that, but okay. So let's unfortunately spend a few more minutes on theory because it's very imperative that we do that. An intuitive graphical user interface dashboard. That's pretty cool. So this is probably going to be useful to us, right? Shit. Oof. Yeah, I can't read all of this now. It's too much. I'm too tired to I mean, we cannot. No way. We cannot. We'll go top-down approach, right? I'm sure one day, or I hope one day, we might understand this, but we can't go this bottom-up approach now because this is going to take 3 days just reading theory, right? So we can't afford that time-wise. So let's go top-down approach of learning here, and let's just try to make it work, and then try to fail with it, and try to then bring ourselves to the points of needing to understand these things while debugging and stuff, right? So that's very difficult. Okay, this is some terminology. That's cool. So we would definitely host this on K3S, right? How can I check the? Can I do like? Okay, so we are on the latest version. That's good. Okay, give me a second. Let me just plug one more drive because they suggest over here minimum of 3 disks, right? What was it? HTOP? No. So I have 4. So yeah, these are quad core, right? Okay, so it should suffice. So these Raspberry Pi. Let me plug one more disk here. Give me 1 second. Alrighty, so I've plug this one, I believe, in the. Give me 2 seconds. I think over here. No, I'm not attaching it. I'm attaching it to all different nodes. It makes no sense. For sure. Yeah, absolutely. We would definitely not do that. Makes absolutely no sense. Yes. They're all attached to different. They're all attached to a different thing. Absolutely. Absolutely. They're all attached to a different thing. Okay, so let's just go. Give me a second. So let's just do this once again here. So what do we have? We have SDA1, right? So let's see. Let's unmount it. Of course, it's not mounted. Beautiful. And then we do this, right? We say D to delete. Right. Beautiful. No, actually, yeah. So delete, nothing to delete, probably. Yeah, create a new one. I'll order 2 more hard drives for sure. I think we'll need them because. Okay. And then let's do the same steps here. I should have just ran the our Ansible thing, but it's okay. So we do this. Cool. Great. And then let's do the mounting and stuff, right? So we're gonna do the so we need a super user, right? Cool. And then we'll need to mount it, right? So sudo mount dev sda1 mount storage, right? Nice. Then we're gonna reload. And I'm gonna check now my power consumption of the cluster, because now when we have plugged in 3 additional drives, give me 1 second. Let me just check the power plug. I have the smart power plug. Let me check what is the electric now. Yeah, so we basically went around 6 watts in power. So around 2 watts per hard drive. So we were around 25 watts. Now we are around 30 watts. So that's interesting to see. So we are around 5 watts up just by plugging these hard drives in. And one of it is an actual hard drive HDD with cylinders and shit. So, and other tools are SSDs, right? Okay, well that's great. It's fine, right? It's okay. I guess there's some ways to optimize that. Did we mount them? Did I just mount them? Yeah, I did. Okay, cool. And we're gonna do df disk free, right? If I recall, yes. So here it is. This one is 1 terabyte. And then we need to do the the same thing. We're gonna grab the UID of this fella over here. And yeah. And then we're gonna add this thing here. So we'll do, actually, let's just do it here. It's easier. Cool. And then, of course, shit. It's this, right? Give me 2 seconds. I'm gonna tell you now. Yes, right? Sure, great. Okay, cool. So in theory, if we reboot, the drive should load on. Let me try to find it. I don't know which Amazon I bought it on. I bought it long ago. Let me see. Yeah, these are not the things we are talking about, right? Give me 1 second. What is this brand? Shit. Gosund. Did I buy it on the co-UK while UK was still a part of the EU? I used to buy things here. Then these assholes left. All right. Gosund. What did I say? Gosund, right? What the heck? But let me find it for you. It's this one, yeah. 100%. I don't know why my I'm very sure that I bought it on Amazon. So I don't know why their search doesn't work actually. Oh, here it is. Yeah. Nah, no. Anyway, it's this one. All right, cool. Okay, let's just SSH here again. Cool. Oh, I actually didn't SSH. Of course, my pleasure. Yeah, so this bad boy is still mounted. Okay, great. So now we have 3 disks, right? So now we have 3 external hard drives, each one plugged in a single Raspberry Pi. Fuck. Yeah, we'll see about that. So because we're not using Helm, we're not using Rancher right now, we would need to install it using kubectl, right? So this is what we need to do. Service account, cluster role. Using Longhorn deployment YAML file. This is reasonable because, yeah, we can run this. I'm sorry. I'm just trying to. So should we? So I suppose we should install this on our master node, for example, set up this graphical user interface thing, and then I suppose through their GUI add the rest of the worker nodes. That's my assumption because it's not very clear from here. Okay, let's interface a bit with the robot, right? Okay. So this is the latest ChatGPT. So I have an OpenAI key. So I would like to install Longhorn on my Raspberry Pi 4B cluster. I have 4 Raspberry Pis with 1 master and 3 worker nodes. By following the official documentation for installation, it's unclear if I'm supposed to install Longhorn on all nodes in the same way, or install it on, for example, master node, and then through their graphical user interface configure the worker nodes. Either way, guide me to the process of installing Longhorn on my cluster. Can I like move this? Yeah, perfect. Okay, cool. To install Longhorn on your Raspberry Pi 4 cluster, the steps are generally the same as installing Longhorn on any Kubernetes cluster. Longhorn is a distributed block storage system, so it should be installed across all your nodes to provide highly available storage. Before continuing, ensure that you've set up Kubernetes cluster with one node designated as the control plane master. Yeah, I'll walk you through high-level process of installing. Okay, so it's telling me just to check the status of the nodes in the cluster currently. So let's just do that here. So they're all ready. Yeah, I don't know what's up with this one, but 11 days, 2 days. So that's great. Cool. All nodes should show up as ready. Ensure ARM64 compatibility. Storage. Each node in the cluster needs a directory to store. Yes. You can use external storage, Kubernetes network, and disk local. Okay. Yeah. I don't want to use Helm as the abstraction takes away things from me in a sense of learning how to deal with K3S without package manager first. What version is this? 1.0. This is... Huh. Shit. So which one should we use? This one that Robot suggested, or the one on their official docs? Yeah, I think this is 1.7.2, and this one, it seems to be the like pre-release or something like that. I can see here 1. So yeah, let's use this one that is suggested by the actual official docs. This one, right? Is that what Robot is suggesting as well? Yeah. Okay. Well, good luck to us. Let's try. Cool. The command will pull the entire Longhorn deployment YAML, which configures everything Longhorn requires inside this namespace. After monitor the deployment process. After applying the manifest, you'll see various Kubernetes objects. You can monitor them with the following command. Cool. kubectl get all. Actually, I don't think that we can use the. Let me just see. I don't think these are just shell. I don't think this. Yeah, exactly. Okay, never mind. What did I want to do? Yeah, going back to the robot. So yeah. So let's see what's happening. Yeah, a bunch of them have errored out. That's not good. Okay, maybe it's just taking long, right? Because it says that it needs to pull all the images from Docker Hub or whatever, right? So let's maybe give it some time, I suppose. No, we haven't gotten to the part of disks yet, right? Now we're just setting this thing up. Then we're going to choose the disks where it's going to store the stuff, right? No, that's not what I want. Where's the... Yeah. Yeah, yeah, it's unclear to me now. How long do we need to wait? So these are crashing, right? So something's off there. Well, what do you mean you should start read the long... can you elaborate a bit more? Yeah, but which pod? I don't think that... Is this the pod failing? C1, good evening, buddy. Good to see you again. So how can we check that? Give me 1 second. And this is just the port forwarding the UI, so that's great. Actually, in fact, let's just try that for a second, right? Because in theory now we should be able to see that, right? Wait a minute. We need to find the IP of that. 2 seconds. So this one here, right? Yeah. 80. Page not found. Okay, well, it in fact it is there, right? I mean, we could also expose it with node port, but this should technically work, so it's probably something wrong. Because right now I can see page not found, so there's probably some admin or I don't know. Yeah, but we'll see about that. Okay, let's try that. Let's see what's failing. So let's try to kill that. And kubectl namespace logs pod name. Yeah, but which pod is failing? That's unclear to me. If we take a look at this. Is this? Oh, yeah, I see. Okay. Sure. You're absolutely right. Carol, my friend, good evening. Good to see you, dude. So the namespace, I guess, is the Longhorn system. And then logs pod name. So let's, I guess, can we just use partial names? Let's say like this. Okay, so we need to use the full name, I suppose. Okay, defaulted container failed to check environment. Please make sure you have on the host failed to execute. Okay, I don't want to pollute this one. So let's open another session here because this one I want to just keep for what we're doing now. Yeah, okay. You need to, yeah, most likely I can see that. Yeah, exactly. You're absolutely right. Okay. On the nodes, I see. Okay. Thank you. Man, don't say sorry. Thank you so much, right? Thank you for participating in it. Don't say sorry. Yeah, I appreciate, man. I appreciate it, dude. And because I don't know what this is, I have absolutely zero idea. I'll just read a little bit about it. The OpenEye SCSI project provides a high-performance transport-independent implementation of RFC. Why the hell would I need RFC? Internet Small Computer System Interface. But why would I need RFC? Like, that makes no sense. What am I gonna use RFC for? Wow, okay. Oh, I need to understand this. Give me a second. I don't know why would I need RFC, right? For this, like, totally have. Okay. I see. So okay. The role of it uses Internet Small Computer System Interface to expose and manage storage volumes within your Kubernetes cluster. When you create and attach Longhorn volumes to your workloads, Longhorn sets up ISCSI targets between Kubernetes and the Longhorn volumes that are stored across nodes. This is where Longhorn setups the targets between Kubernetes nodes and Longhorn volumes that are stored across. Okay, so, well, not to get into too much of a detail, we're going to get depressed. It's needed basically for the sake of Longhorn being able to expose, I guess, or access the volume or expose the volumes across several nodes. But it's needed. It's important. Okay, I'm not gonna. I'll need to read this off stream. I still need to understand that better. To be honest, I'm sorry. Okay, cool. Well, that's good to know. At least on a very surface level. Okay, so that works, right? Let's create a okay. Give me 2 seconds. write Ansible playbook for that. I use OpenAI key. I don't pay for ChatGPT, I pay for OpenAI key, and then I use Lobe chat interface, my own hosted interface. So this is my cost here. So I use OpenAI key, I pay for the key, and then I use Lobe chat, which is just like a UI. So yeah, I just created a CNAME record on my DNS and deploy that. Okay. Let me just, because I don't want to do this on 3 nodes, let's just create an Ansible playbook so we can just install this on all the remaining nodes. So we have installed it now on Raspberry Pi 1. Let's just run the Ansible here. Let's just say playbooks. Let's say, what is this called? Yeah. So just so we don't repeat the same thing multiple times, right? Bam. Copy this bad boy here. Let's validate it, all hosts. I think it's in my inventory, it's called all nodes. We're gonna comment out this one because that's where we installed it already. We don't need this thing, right? Okay, cool. That's great. So I think this should fundamentally work, become sudo, blah, blah, yeah. So let's exit here. Let's go to cd, Kubernetes, Ansible, inventory is good, disable Bluetooth, and then what do we have here? We have install, yeah, let's try that. Nice, okay, cool. So it's running on the rest of them, 2, 3, and 4. Let's give it a second. While that is installing on the remaining nodes, let's just go over here to this previous discussion. So yeah, so once we do that, essentially we need to restart our pods, right? So it's like, hey, you should see output blah blah blah. Yeah, so we're gonna then run this stuff, right? Check Longhorn pod logs. Nice. So nice to actually finally be doing some Kubernetes, at least learning how to manage nodes, just memorizing these commands like for pods, right? So namespace, give me the logs for this namespace and this specific pod, right? Cool. Shit. Let me just, because I'll need to write this in the docs, let me move this to to-do. Let me just save these links so I can then turn this into proper docs and kind of aggregate it and make it more digestible for me and others as well. I don't know why. I don't know why it takes so long to install it, but nice. Okay, I have a feeling in like a minute or two. Beautiful. So it installed it on all nodes. We can kind of see the successes here. Let's just manually validate it. Let's just go to SSH RP2. Great. SSH RP3. Great. SSH RP4. Great. Beautiful. Super nice. Okay, let's go back here. Do this logs thing, but only for the whole namespace, not for a single pod, right? So let's go back to this fellow over here, and yeah, so we do this, right? And yeah, All right, so I'm actually a little bit confused now. Are things working or not? We have these crashes here. Ah, okay, so they were like 3 manager nodes. So I suppose this is the same node. It's just try to, okay. So let's, all right. Is it the same error? Yeah, okay. So now we need to go and do what this good fella told us. Give me a second. My wife is sending me a message of something. Nice. All right, cool. Okay, and then we need to just do this, right? So I'll just nuke these fellas that failed. So I think that's this one, right? So we're gonna nuke this guy, and then I suppose we need to kill all 3 that failed, right? So we'll do this, and we do that, right? So we'll just do this, I suppose, delete it. And now I don't know if it's gonna delete it and restart it, or how does the command work? Ah, it's gonna automatically recreate the pod. I see, okay. All right, I guess it's recreating the pod, which is why we're waiting a bit for some status, for some response. Yeah, let's give it a second. Yeah, I'm just unsure if I want to, should I delete them all? That's the main question, right? Because I'm not sure. I guess I should. Okay, there's only one crash now, which is this one, right? 4x. Do we have it written? Yeah. So this one, okay. So there's only one now that crashed, and hopefully now once we nuke that, we should be good. Because the third one kind of disappeared. I don't know why, but it's gone. And then I'm really hoping that we can then see, we can expose at least with port forward this graphical user interface, and then see, like, can we through that do something? I mean, if we also have to do this installation for kind of everything, we're going to obviously create an Ansible story for this as well and just run it on the rest of the nodes, so that's okay. Let's just see, is there anything else crashing? Container creating, so it's still creating that. There's nothing failing yet. Let's not get overly excited here, because this stuff doesn't seem easy at all to be. I mean, running these copy-pasting shit is easy, but figuring things out. Okay, good. So everything's running. Great. Cool. Super nice. Okay. So I'll go back to this bad boy here, and now in theory, we should be able to port forward and then have something seen on this specific host here. So 192, not the Nginx though. So why can't we access it, right? This is for sure my host, right? So this is the IP of my Raspberry Pi 1, right? We can see it here. 8080, isn't that what I wrote? Yeah, it's 8080, right? I mean, we should be, right? So that's a bit weird. Ah, we can't, of course, do that. Yes. Shouldn't be pinging myself. So is there some firewall rule or whatever? That's weird. Okay, let's take a look. What is this bad boy saying here? I mean, we can do the node port as well, right? I don't mind. Yeah, let's maybe do the node port for now, right? So instead of the port forward, let's just expose it outside of the cluster, right? That's what I remember. So we do this. We smack this boy. We create that service, I guess, and then we now inspect the service. Let me just memorize this: kubectl get service longhorn front end. Yeah, I see. Okay, the port forward. Okay, before I do that, give me a second. So what is actually exposing outside? I think it's the port 3000. There we go. There we go. Cool, cool, cool. Okay, that's great. That is super. Nice. Actually, it's reading all the nodes. So we need to now add the drives, like, because I can see that it's not reading external drives. So we have to somehow tell it, hey, my friend, you know, I actually have a big ass drive. You shouldn't be using the SD card. So this is good. Do they have a dark theme here so our eyes don't bleed? Is there like a theme or something like that? Otherwise, we can install some Chrome extension. Actually, believe it or not, it's proven scientifically that it's more healthier for you to read. I agree. I 100% agree. But if we are to trust these scientists, or maybe they're just under quote scientists, apparently it's healthier for you. Okay, Chrome dark mode. Let's just install the dark mode just for the use case of this. Nah, not that one. There's a better one. Is it this one? Nah. Oh, manage dark mode in Chrome. The hell I do that, man? Nah, okay, never mind. No, I think I've done that already. Anyway, let's find some, yeah, let's just install this. Let's try. All right, cool. Raindrop, no, that's not the one. So where is it? Ah, shit, no. That one is the best. Okay, cool. Yeah, I've actually used this, but I removed it. I didn't need it anymore. Yeah, you're absolutely right. You're absolutely right. Okay, cool. So let me just remove the dark mode one. Remove. And then let's use that fella. So let's pin it. Okay, now we can see a little bit better. Okay, cool. Great. Okay, so let's learn a little bit about this user interface. So one thing that I can see is that Longhorn already sees our nodes, right? RP1, RP2, RP3, RP4. So that's awesome, right? That's great. Volumes, though, it doesn't actually have any volumes. So I suppose that we have to attach volumes. So let's try to figure this on our own. So we say create. And then I guess here we'll need to fill in this stuff. Like we need to tell it, hey, which drive from where, blah, blah, blah. Name, number of so we want 3 replicas. Okay, let me not pretend that I have any idea what I'm doing. I do not. Let me just, let's just sneak around a bit. Let's sneak around a bit before we use internet, right? What is this crap? Okay, we have some events, event log. We have some event log, and that's cool. That's great, I guess. So we have the nodes. That's also cool. What can we actually see here? Edit nodes and, okay, So I can actually click here, edit nodes and disk, right? And here I suppose I can give it a, so I can see that it's not, okay, so I can click add a disk, I suppose here, my camera is maybe a little bit too big, shit, that kind of sucks. Maybe I can zoom out a bit, yeah. Okay, so here we're adding the disk, instance manager CPU. Okay. So 100% this is it, right? So we provide the mount point. So we say empty mount storage, right? Scheduling, eviction request. I have no idea what that means. Name, we can just call it storage, I guess. Storage reserved. Also don't know what that is in this context. New disk tag. File system block. I guess we want to use it as block, not as file system, right? We want to use it as block storage, I suppose, right? Scheduling. Scheduling of what exactly? Like what type of useless shit is this? Scheduling. Scheduling of what, man? How do I know? Like eviction requested. I have absolutely no idea what that means in this context. Scheduling. I'll just enable it, but I don't. Yeah, actually, let's not just do anything. Okay, let me just go back a bit here, just so we see what's happening. Okay. Longhorn automatically recognizes your Kubernetes nodes, but you may want to configure how disks on your nodes are used for storage. Interesting. You can do this through the Longhorn UI under the node and disk section. Here you can determine how much space is allocated in each node, specify custom directories for disk storage, mount disk instead of default paths, set replication factors, how many copies of a volume will be stored across nodes. Test Longhorn creating a PVC. Let's verify the Longhorn is working by creating a test persistent volume. Here's you can create storage class and okay. Big Blaster, my friend, good evening. Your haircut looks incredibly sharp. Thank you, buddy. It's my wife taking my wife is saving me money. I'm loving this Kubernetes journey. Do you think I should do the same thing as Learning Aid? And what will you use Cluster for when you're completed the project? Should you do the same? I mean, I think what you should do is probably follow what I'm doing here, right? That's my take. Why? Because you would duplicate the same crap pretty much. I think you would land pretty much on some same... I mean, my literally goal is to have write the best repository that exists on this topic. I'm not exaggerating. Okay, maybe I am exaggerating a little bit, but I'm not. It's not intentional. But I think it's fun, man. I think I intend to probably move Programmer Network to it, so not to host it on Hetzner anymore. So, and we need to read what Emma wrote, but yeah, I mean, yeah, probably this. But either way, like I intend to use it for various... I mean, I will be streaming on and off for probably years to come here, so, and we'll do projects together for sure. And I intend to be able to provision an awesome stack like Go or Node.js API with a database and Redis and blah, blah, blah in 5 minutes. And you having access to it in 5 minutes as well. You know, so Ingress... etc., etc. So what I intend to use it for is anything that I need to host, I would probably host here. That's why eventually I really want to have 2 master nodes, because the only thing that scares me, so there's 2 things that scare me. Power, like losing power, which never happened this apartment yet. And second, you know, you cannot claim that something is high availability if you still have a single point of failure, which in this case is a singular master node, right? So if my Raspberry Pi 1 would fail to work, then the whole cluster goes to shit. So the only high availability thing that I'm worried about is that. Once we also cover that, so I'm going to probably either get one more one more Raspberry Pi or a few more, or just make another one of the other ones, another master, then you can say, okay, now we have, we're going to have hopefully Longhorn. So we cover the high availability of storage and redundancy, and then we have another master node, and that would be cool. Should you do the project like this, you can also do this project by investing nothing, right? So you can set up 4 virtual machines on your computer and do it like that. So you don't necessarily need to spend the money as I did, right? Like there's a lot of hardware here that we bought. But if you're a developer and making money, right, this is a very cheap investment, right? And it's something that you're going to have for years, right? I mean, these Raspberry Pis, they don't die overnight, right? For sure. I mean, rest of this stuff certainly doesn't die. Like, a MikroTik router is a good investment to have in your house anyway, regardless if you want this or not. Having a cabinet also is something that you can use for decades, right? Unless you have a kid that breaks it or whatever. So should you do it? Yeah, I think it's very fun. And this project is going to take us a very long time because fundamentally we're doing so many things, right? And I think it's incredibly rare today that it's going to be more and more rare for developers of any kind to do bare metal stuff, because more and more cloud services and even some open source services, which you don't have to use GCP or AWS or Azure for, they're removing this pain from us, right? So I think if you want to kind of understand end-to-end how things work, I'm not just talking about Kubernetes, I'm talking about system level stuff, I'm talking about disks, I'm talking about the networking layer, from layer 2 and up to layer 7 to all. I think it's incredibly fun to have something where you can always remind yourself. I worked as Cisco engineer 15 years ago or more, right? And I forgot a lot of stuff because I haven't worked with Cisco in a long time. So having these things that you can maintain and break them, and then you need to set them up again and stuff. Yeah, 100%. And I think it's very different when you have physical hardware as well. It's a different feeling. But again, you can mimic this same crap almost fully with just virtual machines, right? Or you don't even need virtual machines. You can just create different Docker containers on your computer, right? And treat them as different computers, right? Does your ISP get angry if you get DDoSed or you get millions of hits per hour? I don't know, actually. That's a good question. I have no idea. I don't know. I don't know the policy of that, right? It's a good question. I don't know. I can't. I would not even dare to give a vague answer on that because I don't know. And yeah. Haven't been around much here or any social places. I lost my job in August, so have spent more money looking for work, trying to get on with part-time university studies and pick up some new skills, qualifications after getting a cybersecurity certification. Wanting to get more experience in that area, I set myself a new project. I'm working on building a full SOC stack with a small corporate environment and fake internet to hold a Kali VM as a threat actor in my home lab. I see. I lost my job in August. Emma, are you there? I don't know if Emma is still here. Yeah, I'm sorry to hear that. But it's also good that you are just continuously working. That's how it is. Yeah, I hope that you're also applying for things while working on your side projects. I mean, ISP is right. I mean, ISPs in general, right, are dealing with DDoS attacks, regardless of if you expose your IP or not, right? I mean, DOS or DDoS, distributed denials of service, right, are things that are not common to somebody sharing an IP. You can DDoS nearly anything today, right? So I mean, find any IP and DDoS that. You get what I mean? So DDoSing is not something that's hard to do, right? You can sniff any IP nearly. You can find random IP of someone and just send shit tons of traffic there. You just don't know what it is there, right? So fundamentally, that's not like some sort of thing that rarely happens. I mean, anyone can DDoS anyone almost. I mean, if it just now depends where the traffic ends, right? There, of course, mitigation ways to mitigate that, either through the firewall sending that data nowhere, or before firewall, or on a lower network level, right? So of course it depends on the scale of that, but fundamentally that's not some sort of a thing that's hard to do, right? You can go to any website now, find their IP, right, and DDoS them, right? I mean, that's not a hard thing to do. So being worried that somebody is going to DDoS you specifically, I don't have that fear, because again, you can DDoS anybody, right? It's not, you can go play a video game and use Wireshark, figure out the IPs and stuff, and just DDoS them as well, right? So it's not that I mean, it's not that that's something that's hard to do, or especially if you have good internet and if you call 10 of your friends and say, let's do it together, right? So, and that is probably the downside, right? That is potentially the downside of clusters like this, right? Like, more of that you would have to deal with, better router you would have to have, right? So for example, you would probably want to have a 16-core or 32-core router, because even when you firewall this traffic, let's say that somebody's DDoSing you, you see the IP ranges coming, you're like, yeah, let me just block this, right? Well, it's not that simple, because your CPU still has to process some of these headers, read the IP from the headers of the request, and then still kind of say, yeah, this data should not go there. So even the firewalling part is difficult, because it's still processing some requests and then saying, well, no, this cannot pass through. So that's why having a real data center is a different story, is because these guys have a huge networking Exactly, right? I mean, the thing that I would do if I get DDoSed, I would just shut down the router and that's it, right? It's not rocket science, right? But I guess my point here is to say you can get DDoSed anywhere, right? That has very little to do with it your own bare metal or something else, right? And of course that, yeah, GCP and these platforms are great at mitigating that. Google Cloud Platform has this Google Armor. They call it Google Armor. And this Google Armor, for the most part, does work. They have very good algorithms they have a lot of data, a lot of great algorithms that you can see benefit from DDoS protection and WAF at Google scale. Cloudflare has solid DDoSing, right? So in Cloudflare, for example, let me show you. If we take a look at Cloudflare, for example, but there are ways around it, right? There's way, of course, I'm not going to expose my IP. All the traffic will go through Cloudflare. But for example, I believe if we go to No, but it's a great suggestion, right? But you can actually see here. So if we go to security over here, was it here? Wait, I can't remember. But yeah, you have DDoS here, right? Automatic DDoS protection that constantly analyzes traffic and generates real-time signatures to mitigate attacks across network, blah, blah, blah. So if you, in practice, which is what I did for Programmer Network, if you basically do something like this, you say, hey, you know what? I will only on my unified firewall allow traffic from Cloudflare IP ranges. So this is public internet, this is your server, and then this is your router, your networking stack. Here, potentially, you could do it as well. Now, of course, unfortunately, in this case, right, it will be pretty much like this, right? So you say, on my router, on my firewall, so for example, in our case, if I open my own Winbox here for me, that would be here, right? So here, I would create filter rules. I would say, hey, I only want to forward the data that's coming from the source address, whatever, blah, 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 or the ranges, right? But again, still my router would be under huge load because it still has to, at the end of the day, firewall is still just a software, right? And that traffic is still going to the hardware, right? So yes, you would prevent the traffic going through to your network internally, but I mean, your router would still be bricked because there's so much data coming in, right? So ideally you would have a real, but that's very hard to solve at home. You would actually have something in front of your router, but that's almost impossible, right? Can I check Discord? Yeah. Hopefully it's nothing private that let me open it up. Let me just move it to a different screen. Sorry. No, I didn't expose. That's not my password. That was Cplane. That was suggested password. If you mean that hash that you saw, that is a suggested password. It's not my password. I think you saw. I think what you saw here was a suggested password, right? When I click this is not my password. This is just suggesting a new password, right? So don't worry. But thank you. Thank you for saying it. But that's not my password, don't worry. Yeah. Don't worry, I also tripped for a second. But no, this is just suggesting. Yeah. Anyway, you can see with Google Cloud Platform and stuff, you get these things like layer 7 DDoS attacks, for example, right? Amazing, right? But you also get it for free on Cloudflare pages, right? On Cloudflare, well, pages as well, right? But you also get it here, like you get a WAF. For example, I can show you one more thing very quickly. Cplane, thank you, man. I love you. Thank you for caring about that. But don't worry, I try hard to not do that. So if we go here, for example, right? Let me show you very quickly. I mean, Cloudflare is absolutely amazing. It's my. So if we go here, if we go to security, right? If we go to security and we go to WAF, right? WAF, zone level web application firewall, right? But I actually need to do that on a different level. So I'm just gonna go here. I'm gonna go to websites. I'm gonna go to programmer network, I think. Give me 2 seconds. Security. WAF, is it here? No, it's not there. Shit. Give me 2 seconds. WAF. Crap. No. I have too many things, man. I don't. I need to remember where it is. Too many things. Websites. Programmer network. Rules. Ah, fuck, this is a new thing. Wow, they have changed something here. Wow, this is super awesome. Okay, but that's beside the point. Where is it? Configuration rules. Yeah, they changed this UI a lot. Crap. Page rules, maybe. Wait. Yeah, but that's not what I want to show. That's also super nice. But I want to show something else. Yeah, that's so weird. Page shield. Never mind, I guess at this point is beside the point. I can't find which account is it on. cloud for pages. Let's try this. All right, never mind. I kind of got bored by looking at it. But anyway, it's amazing what you can do there. Let's go back to this. I have 43 minutes and I want to stop at that point, so I really want us to do this. Okay, so what this guy is telling us, okay, test Longhorn, creating a PVC. Let's verify that Longhorn is working by creating a test persistent volume claim. Here's how you can create a storage class and a sample PVC. To create a storage class for Longhorn, you need to do, what is a storage class? But can't we do that through the UI as well and then inspect? I guess we should be able. So here we have volumes, right? We have backups. That's so nice. Engine image, orphan data, backing, instance manager image, system backup, dashboard. So I mean, we have all the nodes here, right? And for each nodes, we can actually add their disks, right? So let's actually try that. Let me just try it. So for the Raspberry Pi 2, I'm gonna edit. Kernel module not loaded, okay? Okay, let's add a disk. We're gonna say a storage. We're gonna give it a path mt storage scheduling. I don't know what scheduling is. Rebecca, my friend, good evening. Let's save. Okay, did we add a disk? Unreachable. Yeah, I've added that because I want to go to the gym and I want to make sure that I don't end up streaming the whole, like 4 hours or 3 hours. So I just put that for myself there. Oh, okay, schedulable. Okay, but it's a file system. Shit, that's not what I wanted. Okay, so it's reading the disk now, but that's not really what I wanted. So what I wanted, I guess I want that not as a file system. Can I remove that? Yeah, so can I remove it? Okay, so I'm gonna try adding it again, but I'm gonna add it as a as a block, not as a file system, right? So we say storage, we say mnt storage, true save, right? Pretty much, Rebecca, pretty much, exactly. Okay, let's try something else then. Crap. I'm just pretending, I mean, I have no idea what I'm doing, but I'm poking a bit. So, okay, well that we can do, I guess. Disabled. Thank you very much for the follow. Appreciate it. Disabled. Why the hell is it disabled? Storage, blah, 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 scheduling. Okay, so now it's reading it again. I can see that it's reading that crap, but it's still disabled. I don't know why. Okay, ready, schedulable. Crap, okay. I guess, yeah, let's enable that. Schedulable, okay. So I guess we've done something now. We have exposed this external drive, and I guess we can do something. If we go to volumes now, and then we create a volume. And then there's these disk tags, node tags, data source, volume node data, volume snapshot, okay? Block device. Okay, so if I edit this fella over here, storage reserved. Okay, so we reserve something for whatever. Cool. And we can create these tags. I wonder, like, what are these tags used for, right? Let's see here. Does this guy create any tags for some way of then using them for something? Okay. Okay, crap. Let's just try this. What I'm gonna do, I'm gonna nuke this, save that, and then we'll need to figure this out. So let's go over here and let's go to docs, and then getting let's say Longhorn. But for now, then I'm not gonna commit that anyway. Ah, crap, this is not the docs. Okay, never mind. So let me nuke that. And then over here, I'll go to... Let's just create that folder here, Longhorn. And what are we trying to do? We want to Longhorn storage class. And we need to learn what the hell is storage class. I have no idea what a storage class is. Okay, we're going to do this. Create a PVC using Longhorn. Ooh, okay. Ah. Shit, man. Wait, interesting. This I can almost understand. Wait. Like I kind of, yeah, okay, bear with me. Okay, because you can see, so we essentially, so it seems that Longhorn is a way to kind of expose some drives, some data. It's like, hey, this is what we have, man. Like we have these two pies, we have these two pizzas, and there's like 8 pieces of each, and you know, take as much as you want. But that's how much. So, because here we can see request storage. So basically, we are like, hey, how would we say it? Provision a persistent volume, and I want it to be 2 gigs of data. I want read write access. I don't know what once means. Blah blah blah. Storage class name Longhorn. Also don't know what this does, but we'll see. And then so nice, dude. So nice. Okay. So you can see here an example with Nginx is like, hey, I want to provision Nginx, volume mounts name data, mount path this, and then we have persistent volume claims, and then we give it a claim name here. So that's how we basically give that specific container, a service, container, some volume, right? What is it? Okay, I need to chat a bit to the robot. So what did we create here? We created a, what is a storage class, and what is exactly? Explain in simple terms. Robot, yeah, sure, let's dive into Kubernetes. Storage class. Think of storage class Kubernetes as recipe of blueprint that dictates how to create storage for your application. Okay, so that is like a brain of like, hey, I want some storage for something. And then Kubernetes, you often need to store data like database data, logs, and different applications might need different types of storage. Some want fast, some want big. That's what she said, and some want highly replicated storage. To solve this, Kubernetes uses storage class to define how storage should be provisioned. Okay, so this guy tells us, hey, we tell this guy, this is what I want. Storage describes type of storage. It can be based on speed, redundancy, storage, provider, driver, or other properties. I'm sorry. I was just, once defined, the storage class allows Kubernetes to automatically give the right kind of storage to any service pods that asks for it. So instead of worrying about how to create storage for your specific application, you just pick a storage class and Kubernetes takes care of the rest. Kubernetes sends the request to the configured storage system. Simple analogy for storage class. Imagine you're at a pizza restaurant. You want to order pizza, but you don't care about how the kitchen makes it. You just describe the type of pizza you want by selecting a predefined option. Regular, thin. The kitchen, in this case, Kubernetes knows how to create the pizza based on those conditions. In the Kubernetes world, the crust and cheese options represent different types of storage like Longhorn, AWS, CBS, Google Persistent Disks, SSDs, etc. A persistent volume claim is your way of asking for a specific amount of storage. Exactly. It's kind of like saying, hey, I need 10 gigs of storage. Exactly. And that's why I said here, yeah, right? Hey, I need 10 gigs of storage that I can use reliably and persistently. And persistently, I guess these two are, there's an emphasis on this. Because I guess some data is not persistent. It might be some other type, right? And that's the kind here. So this is basically, I suppose, is it persistent? Volume claim or like, so I get it. Okay. A PVC is a request for storage. In the PVC, you specify how much storage you need and what kind of access you need. Is it read only or read write? Amazing. The PVC gets matched to a persistent volume, an actual piece of storage, through the storage class you define. Okay, so in a nutshell, right, if we are to draw this, which we should, right, so here we are like, we have the PVC, and here we say, no, we have the storage class. Let's just like make sure we understand. We have the storage class, and here we say, hey, I want this type of storage. I want this type of storage, and I guess some other things. And then here we say in the PVC, and what was the PVC acronym for? Persistent volume claim, yeah. We say, I want 3 slices of pizza, but I only want to look at them. Read only. Or I want to eat them and rub them all over my chest. Right? Because of course, I hope that's where everybody does when they order pizza. They rub it all over themselves, right? So that is basically that, as far as I understand. In simple terms, imagine your PVC is a rental request form. You fill it out, specifying how much storage you want, like how much house space you need and what type of house you're asking for. Once Kubernetes finds matching storage, persistent volume, it gives you the key to that house or disk. So the PVC connects you to that storage, and you can now use it for your application's data. I mean, this AI shit, man, is just fantastic. I mean, if somebody says otherwise, you should just not use computers, man. It's absolutely insane. Like, Because when you dumbify these intelligent sounding terms into simple analogies, it's so simple it makes sense, right? When you make this request, so simple analogy for PVC, let's go back to pizza restaurant analogy. I want a pizza that's 12 inches large and it should be thin crust. When you make this request, the restaurant Kubernetes will look at the menu storage class and find the right recipe or profile that matches your request. Bake a pizza based on the recipe, allocate persistent volume. Yeah. Man, this is so amazing. Fuck my life. This is so great, dude. This is actually even better than I anticipated. It's so amazing, man. Oh my freaking god. I'm mind blown. I'm mind blown how awesome this is, dude. Mind blown. It's so awesome, dude. Like, it literally feels like you have your own data center. You provision some crap. You don't think, like, you can of course keep in mind, have some dashboard somewhere that shows, okay, how much total space we have on hard drives. Sure. But this is just a no-brainer, man. You're not thinking about drives or disks. There's no concept of, oh, on disk F, put this, right? You're just like, give me 10 gigs of memory. And that's it, right? You don't give a shit, right, if where it is, right? So just the way that you think about it is so awesome, right? You're not thinking, oh, I want 5 gigs on a drive C in here, right? So what it did, it just abstracts this away from you. You just declaratively, like this, explain that you want this, and you want this type of permission, and blah, 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 and you get it, right? So awesome, dude. That is so cool, man. Wow. That is amazing, man. Absolutely amazing. We just need to figure out here. So we need to just figure out, I want to figure out, like, because I feel that right now, if we run this, it's going to store stuff on my Raspberry Pi cards. And I don't want that, right? Because you can see there's only like 40 gigs of, actually, how big are these cards? Because I have 64 gigs, right? It's these extreme. I bought an extra one as well with these drives. So basically, we need to first set up these drives somehow. And then when we start provisioning these things, it's like storage class name. What is that? So storage class name Longhorn. So we're saying here that the storage, I guess, should... So this is just metadata that this can be banana, I guess. But this storage class name means probably to... It's a reference to Longhorn in some way or form. Let's see. Okay, so this thing means use the storage class, right? So it's like, give me 2 gigs, use storage class, meaning this. Give me the read-write access with this many gigabytes. And then use the number of replicas 2. Okay, we probably want to set this to 3. So it's just, okay, it would be nice over here to be able to provide the hosts, right? So here I would like to say, well, you know, how... Actually, you know, let's use the Copilot chat, right? How can I provide which hosts these replicas will be on? What the fuck are you doing, man? I'm talking about the Longhorn configuration that I have highlighted, right? All right, I think it's not getting it. It's not getting the context. Let me just give it a. Let me just give it this thing directly. Is there a way to decide which hosts these replicas will be created on? Because I have 4 Raspberry Pis. Yeah, yeah. Okay, labels. I see. So there is a way. I mean, I don't have to figure it out, but it's great. So here, as you can... So over here, we would say node selector, I suppose. And then the node selector, we would, I guess, use a tag of some sort of label. Okay, so I see. So basically, when we run... I see. Okay. Very good. So we can do that. Okay, so we have basically created this storage class name ourselves. So it's not like a hard-coded reference, a pointer or whatever. It's in fact something that we have created when we ran some of these. So it's good kind of to go back, go a little bit backwards in time. That's why I didn't want to read all of that theory initially, right? Because... yeah, but I don't think that then this is accurate. I think we call it a Longhorn system. That is the namespace at least, right? Oh, never mind. This field specifies the storage class Kubernetes should use. Longhorn, this is the name of the storage class that you or the sysadmin have created in your cluster. In this case, the name is Longhorn. The storage... Yeah, but I don't think so. No, I don't think that this is metadata. No, this is very imperative, right? Here we have to literally say what the storage class name is because it has to be something valid. So yeah, maybe this, you're right. So we are referring, so when we actually create a storage class, it's going to have a name. Okay, we haven't actually done that yet. So when we create the storage class, we're giving it the name Longhorn. And then when we create a PVC, I can't memorize the acronym yet. Yeah, exactly. Persistent volume claim. Yeah, exactly. Right. Okay. Good. Okay. Let's try this. I mean, it's not that something's gonna happen anywhere, right? So let's try that. So if we go a bit up. No, that's too complex. Let's not do any databases yet. Let's just do this super simple thing. Actually, let's do all 3, right? And then let's provision an Nginx, for example, right? Why not? So let's say here Nginx pod YAML, right? If that ends up working, it's going to be great. Okay, so let's now try this. Create a Longhorn class. So we're going to create a storage class. So we're going to say we'll just exit this session, and we'll say this, and then we need to point to exercises, right? Exactly, exercises, Longhorn, storage class, right? Let's try that. Resource storage class is missing the kubectl last applied configuration annotation, which is required by Kubernetes apply. Should kubectl apply should only be used on a resource created declaratively by either create config or. Okay, I actually have absolutely no idea what that means. 0, like the error you're seeing is related to how Kubernetes handles updates to certain fields in the objects. Thank you very much for your follows, fellas. Okay, did we run something wrong? All right, so here, right, that's what we ran, Longhorn storage class, and that farted out, right? Storage class, yeah. Oh, shit. Crap, wait. I think we're supposed to essentially... Ooh. I think I know what the problem is. I just don't know maybe how to fix it. Because I think we have installed Longhorn. So we have basically installed Longhorn on our Raspberry Pi 1. But we don't have the Longhorn on this system, basically, that I'm streaming from, right? So it could be easily that... Yeah, right, the storage class Longhorn is invalid. So... Yeah, let's see what this bot says. Oh, I see. The Longhorn, okay, storage class is already created. You cannot modify or claim. Okay, I see. Yeah, okay. It should be working again, right? Yeah. Give me 2 seconds. Is it the right one, though? Properties. Yeah, it is. Okay. Yeah, so you're absolutely right. You're absolutely right, which means we can just try running the PVC now, right? So we can just say PVC. So that works, right? Nice. And then we can try doing the Nginx. Okay. Let me just get to that point. Real example. No, that's not the one. And how can we actually inspect this pod now? Like, how can I do kubectl pods or something? Wait. How can I see the pods? Is there help or something? Thank you guys for your follows. I appreciate it very much. Just spawn more resources. Okay, so here it is. Get pods. Okay. But I guess this pod is this accessible somewhere now? I mean, we have created I mean, do we need a service of some sort now or stuff, whatever? Because now we have that, and then we have the pod. We have an nginx thing. So how can we? I guess we would need to create a service now, if I'm not mistaken, right? That's actually deploy a simple app. Yeah, that's the problem, right? We haven't actually done any of that. But there is a service here, but if you don't point the namespace, Kubernetes is pointed to default, sure. But the thing is, what I'm unsure now about, right, is that here we haven't actually provided any ports or anything. So I suppose that this is now actually running, but it's not bound to anything. So we can't really access it, right? Because if I take a look at my, so this nginx pod, right? If I just close a bunch of this stuff, give me a second. So if we take a look at the exploit, like the deploy simple app, right? Exactly, right? So I think we have the volumes and stuff spec, right? Yes, spec containers, right? Blah, blah, blah. Ports 80, right? So here we would need to do this, right? Ah, shitty formatting. That sucks, right? Yeah. So we're missing that, right? And then we need to I think. And then, yeah, like you said, we're not giving it. Ah, okay, so don't do this. Okay, but how can I then? Okay, so. Oh, this is kind pod. Sorry. Shit, man, you're right. That's literally what I just learned. I didn't even know there's a kind of pod. Okay, so this is now describing the pod, right? Not the deployment itself. Okay, I see. So can I somehow create a deployment now that's pointing to this pod? Is that how it works? Because I don't think so. The pod is the smallest unit, right, in Kubernetes. So how would I then deploy this and then expose it, right? So say I want to deploy it and then expose it either as a cluster IP or node, right? Okay, let me ask this. So how do I deploy this pod and expose it as node then? Exactly. Good. Actually, I'm happy. I'm happy because I'm kind of starting to think this through properly. So that's very good. That's very good. I'm very happy. I'm starting to think it through through as Kubernetes is, right? So that's very good. So my assumption was correct, right? I think the only thing that's now telling me here is like, hey man, you need to annotate this. You need to you need to annotate this as. So if we go to the nginx YAML, it's telling me to smack this guy under the metadata right here. And then we need to apply the service, right? Cool. And then, okay, good to know. New command, kubectl get services. Now we have the nginx service. It's exposed in the nodes board here in 3008. 80. So if we go to my browser in theory now and copy this crap and use this port now, it should show us the nginx page, right? I hope so. In case I've actually, fuck. I'm such an idiot actually. Because now, shit, no, never mind. It's fine. It's fine. I know what I've done. It's just I did it on a wrong node. Yeah, that's probably not gonna work. Give me 1 second. It's available on all nodes, exactly, but why? The problem is I think that I've deployed this on this machine, not as part of the cluster, because this thing here, but can that really be the case? Because this thing get services. So why cluster IP? Yeah, so why can't I access that? So this is on port, and this is the port, right? So it should be like you're saying, like this guy is, right? So we should be able to access this really pretty much in this, yeah. Yeah, unless something's wrong. Most likely something's wrong because I can't access that for some reason. Node port nginx service. What was it? So what do we have? And yeah, node port, target port 80, port 80. Sure. So that should be correct, right? How can we inspect the service or whatever? Can we see some logs? You know, are we like, huh? This is a strange IP though. This is a strange subnet. What the fuck is this? Yeah, that doesn't kind of feel right, to be very frank with you. It's internal. Oh, I see. Well, huh. Okay, let's see. Actually, describe. Yeah. To RP, successfully assign default nginx to RP1. Oh, I see, I see, I see. Aha, okay. Okay, node. So this is the node, 242. So yeah, that is the RP1. That is the RP1. Where's the port? I don't see a port anywhere. Ah, here, none. What? So it's not exposing any ports. How is this possible? It's already true, but that's weird. So the IP is correct, you could say. Yeah, right, exactly, right? Yeah. No, that's fine, because yeah, it kind of looks weird. Let's just confirm that. It just, don't I need to expose a port here? Container port. Okay. I mean, I'm just... we can just... Okay, I see. So we just... sorry. What happened there? Oh, we probably have invalid configuration of some sort or whatever. Okay, let's try that again. In case that's actually correct, but it doesn't like something. Okay, so it's not allowing us to update it, so I suppose we have to... Exactly, it's just how do I do that? How do I delete the pod? How was it delete? Kubectl delete node, or delete pod, right? So get pods, nice, and then we want to do, right, delete pod, right? And then I think it's called nginx, okay? nginx, nice, okay. Then we reapply the bad boy. It's created. I don't know now if we need to do really anything else. Describe. If we scroll now up, yeah, now the port is 80 TCP. So in theory now, this service is still running. I don't know if we have to restart the service. Doesn't seem like it, right? There we go. There we go. Nice. That's it. It worked. Cool. Nginx. Nice. All right, cool. Well, that's a great timing, because the time is just up. Get Goofer. Good evening, buddy. How you doing? So that's perfect. We just the timer just ended. So that is super. This fella just ended, which means we should round up. But overall, I'm super happy with this. Super happy with this. Super happy with this, I must say. Get Goofer. So we just learned some Longhorn. We learned about storage class, about PVC. I learned some new commands for Kubernetes for managing pods and a service, and I learned this new command, describe, to basically get some configuration, networking configuration about the pod. No, not yet. We'll get there. I just want us to set up the storage first, so we can set up the database. So basically I want to separate this into like not mixing up too many things. So first part that we did, and we're not fully done, it was like, okay, let's set up these devices literally in like a let's disable Bluetooth and Wi-Fi and this right. Let's do all of these things, and then let's let's then set up the Kubernetes and the storage, so we can then deploy the database and some services, and then eventually we're going to do Ingress and load balancer, Metal load balancer, and Cloudflare and stuff. It's this hardware here. It's 4 Raspberry Pis with 4 hard drives and MikroTik router. Actually, didn't I like share the link with you guys? Yeah, this is, if you guys kind of want to follow or interested in a similar thing, please give it a star. There's a bunch of changes we did. I didn't update that yet, but if you want to follow the progress, that's where I'm gonna be kind of saving all of these things, etc, right? So if you care, give it a star. If you don't care, don't give it a star. That's up to you. But either way, yeah, that repository eventually is going to be awesome, because we're going to document literally everything from A to... You're going to stick with traffic. Okay, just to establish something. I'm complete beginner in most of the Kubernetes. So based on my research, I would be better off with Metal load balancer. Basically, with that thing, why can I give you some rational responses? Of course I can't. I don't know. It's just based on my research that was suggested instead of traffic, or whatever you pronounce it. Ingress control. To be very frank, Nginx would be great. I've been using Nginx for 2 decades, so that would be probably easier for me. But to be very frank with you, I don't know. I'll figure that out with you guys, right? Because I don't know. Works as well. Got it. Yeah. But let's get there. Let's finalize. Setting up the. There's a lot of stuff that I need to learn. Just the basic kubectl commands. I need a few more streams to memorize them fully, to get good at like, oh, let me check this pod, let me check this service, let me check this deployment, blah, 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 right? Oh, I see. Don't confuse. Let me write that comment down in my list so I can actually then get to that statement, and let me just put it here on top of my file. Thank you. And then you don't have to say no more. I'll research why you said that and what it means. Good evening, Arman. Good to see you again, dude. It's been a while. But overall, I'm very happy, and I hope that you guys have learned something new as well. It's super nice project. I think that we can learn a lot, and I don't know. I'm very excited. Because it's a lot of stuff that we're gonna get access to. But seeing the Longhorn, seeing how you think about storage, it just impressed me. It's like, I thought that this is going to be like, put your drive here, and no, it's just like, hey man, can I have X amount of data, X amount of storage that I can read and write for this given service, right? Etc. So that's pretty awesome, man. Like, instead of thinking drives or whatever, you're just like, give me this number of storage, this type of storage. I just want to read it, or I want to write it, or I want to do both, etc., etc. It's just like very declarative. It's very easy. It's very fluid for my mind. It's just like, hey, I'm provisioning this service. It's going to need some data, and this is how much I need, right? Got it. Yeah, right now, no, probably not. Right now, I just need it for a database. So I only need it for a database. I really only need it for, I'm using Cloudflare images for images, so that's that. So I really just need it for database or databases, right? So if you claim that it can handle that then that would be great. I need it basically for Postgres, and I don't know, maybe Neo for J or something like that in the future, Elasticsearch, whatever. But right now, it's really just for Postgres. Nice, nice, great, great, super. All right, well, what can I say? Thank you guys. Thank you very much. Thank you for your help. Thank you for sticking around. Thank you for your help. It's kind of funny. Oftentimes, streamers are perceived as this, monologue type of know-it-all type of stuff. But this sort of stuff that's not very close to me, of course, I learn a lot, if not even more than some of you here. So thank you. Thank you once again, and yeah, I will definitely try to stream whenever I can. Tomorrow, I believe it's Friday, so I have there's a high probability we're gonna continue with Longhorn. But so far, I'm gonna maybe off stream. I'll just play with some of these commands, maybe write some sticky notes, stick them to my screen just so I memorize them, so I can kind of just. That's what I usually do. Maybe a good tip for everybody. Whenever you're learning something new, and some of these commands, you just have to memorize them. There's really no other way. I usually put stickers around my office here and at work, and then once I have them in my muscle memory, I just throw the stickers away. So it's a good, even if I'm not doing, let's say, Kubernetes, I'm doing something else, I'm reading a book on capitalism or whatever, you still every now and then you just see that thing on the corner of your screen. It's like kubectl get pods. Oh, shit, right? So it's more of a subconscious type of thing, but it works. Anyway, all right. I gotta go, guys. I'm gonna go to the gym. It's 10:30 here in the night. It's very tough going to the gym this late, but that's the only time I can go these days. I wish you well. Thank you very much once again, and I'll see you guys another time. Yeah, peace out, everybody, and have a great